Let us look at sequence and series. Now, as our objectives over here, we're going to be looking at sequence and the two main types of sequence is that these are the convergent and the divergent sequence. And also, we look at series. Now, question is, what is a sequence? Well, my way of putting it is that a sequence is a set of numbers where the number in a certain position is generated by a certain rule, a certain formula, a certain equation. And it depends on the previous number, right? This number in this position in the set is generated by the previous number being worked on by a certain formula. Well, that's my way of putting it. So, suppose you have, for example, 2, 4, 6, 8, 10, and so on. Now, this is a sequence, right? You could look at it and say, how did you get the next number? Well, you could say that you add 2 to the previous number to get the next number. So 4 comes from 2 plus 2. This 2 plus 2. Where would 6 come from? First of all, 2 plus 2 is 4. Now, where would 6 come from? It would come from 4, this 4 here, the previous number 4, plus 2. 4 plus 2 is 6. Where would 8 come from? It would be 6, this same 6 here, plus 2 gives you 8. Where would 10 come from? It would be the 8 plus 2, which is 10. You might have 12. Where would 12 come from? It would be 10 plus 2, which is 12. If you have 14, where would 14 come from? It is the 12, the previous number 12, plus 2, which is 14, and so on and so forth. Now, one general rule for this now, you could say it is, if we want to use some letters to see what the formula was, what the rule was that generated the sequence, you could say the term, call it term, in a certain position, call it TP. The term in a certain position is generated from. Now, we say the term in the previous position. Now, if the current position is 5, the previous position would have been 4. If you have the fifth term, is generated from the previous term. So the fifth term is generated from term 5 minus 1. So this is P term. The P term is generated from term P minus 1. Alright? Then you add 2 to it, plus 2. So this here would be a general rule for generating this term. So the first term would be T1. You wouldn't have a term before the first term. The second term, T2, right, is equal to, oh, it would be T1. Here you have T1. Oh, good. This is T1 plus 2. All right. So the second term, in this case 4, you get it from the first term, in this case 2, plus 2. Now the way our general rule would work here is to say T2 is equal to T2 minus 1 plus 2. Because here T2 would be T2 minus 1 is what? It's 1. T1 plus 2. So our general rule here, it works. Alright? Now, T3 would be T3 minus 1, which would be T2. So the third term would be the second term plus 2. Right? And so on. You could go on and on with it. So that's our general rule. Now, let's look at another example of a sequence. Let me erase these things here. We'll look at another example of a sequence. Suppose you have the sequence 1, 2, 4, 8, 16, and so on and so forth. That is a sequence of numbers. And remember, you separate the numbers with commas, right? Now, what do you think the rule is for generating the next sequence? That are the next term. So remember, each number, we call it a term. We have the first term, which is term 1, second term, which is term 2, the third term, which is term 3, fourth term, which is term 4, fifth term, which is term 5, and so on and so forth. Now, here, it seems as if you multiply each term by 2 to get the next term. So 1 times 2 gives you 2. Alright, this 2 times 2 gives you 4, which is at 4. This 4 times 2 gives you 8, which is the 8 here. This 8 times 2 gives you 16, which is the 16, and so on and so forth. So you can see what that is. Alright? So if you should make up a rule for this, a general rule, you would say the term in a certain position is equal to 2 times the term in the previous position. Call it P minus 1. So that would be a general rule for this sequence. Suppose you have another sequence. Suppose you have 1, -2, -5, -8, and so on and so forth. What do you think you did to each number to generate the previous number? Well, it seems as if what you have here is 1 minus 3 gives you -2, right? There. -2 minus 3 equal -5, which you have it there. -5 minus 3 equals -8. Oh, so what you do to get the term in a certain position, to get this term, you look at the previous term, P minus 1, and you minus 3 from it. So TP is T, P minus 1, minus 3. So that's a general rule for generating these terms. Alright? So these are examples of sequence. These numbers that are lined up, each number take a certain position, but you have a fixed rule for getting each number. You do something to the previous number to get the next number, right? And by the way, let us look back at this sequence. The sequence 1, 2, 4, 8, 16, and so on. As we say, you can say 1 times 2 gives you 2. Then 2 times 2 gives you 4. Then 4 times 2 gives you 8. Then 8 times 2 gives you 16. So 1, 2, 1. 2, 2 twos 4, 4 twos 8, 8 twos 16. Now let's look at this. We had said you could multiply each term by 2 to get the next term. But guess what? Let's look at the 2, the 1. Well, we could say 1 times 1 gives you 1. Let's fill this in there. 2. Let's write it as these as the powers of 2. 2 is 2 to the power of 1. You remember your indices, right? 2 squared gives you 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the what gives you 1? You have to remember it's to the 0. Okay. So, here, the first term, we can write as 2 to the 1. That's the first term. The second term, no, the first term was, I'm mixing it up. The first term was 1. So, the first term is 2 to the 0. The second term is 2. Right. 2 to the 0 is 1. The second term is 2, which is 2 to the 1, which is 2. Right? The third term is 2 squared, which is 4. You can see it here, right? That's the third term. The fourth term is 8. The fourth term is 2 to the 3, which is 8. The fifth term is 2 to the 4, which is 16, and so on. So, another way you could write this thing is to say, now notice this first term is 2 to the 0. So the term in a certain position is equal to. Alright. And remember, some books, websites, and so on, they don't necessarily use T for term. Some of them use U, the letter U. As for the position, I use P because P starts position when you're spelling. But some books use R or other letters, right? Alright, so TP equals, what would it be? It is 2 raised to the power of P minus 1. You can see that. The first term is 2 to the power of 2 minus 1, which is 2 to the 0. For the second term is 2 to the power of, the first term, term number 1 is 2 to the power of 1 minus 1, which is 0. The second term, term number 2, is 2 to the 2 minus 1, which is 1. Term number 3 is 2 to the 3 minus 1. 3 minus 1 is 2. 2 to the 2. Term number 4 is 2 to the 4 minus 1, which is 2 to the 4 minus 1 is 3. Term number 5 is 2 to the 5 minus 1. So our rule, our formula, TP is 2 to the P minus 1. It works as well. So the formula we used before, it works. And this formula, of course, it works as well. So that's a sequence. These are for examples of sequence. Now, convergent sequence. This is a sequence, you see, where the numbers get smaller and smaller and smaller. And it will approach one specific number. Alright? Now, let's look at an example. Suppose you have, say, you have a certain term. How do you get it? You take the previous term and say multiply by a half. Alright? So, in this case, you might start with, say, 64. I use 64 for a specific reason, right? I won't be getting any complicated fractions when I deal with this. I will start with 64. This is term number 1. We want the, alright, let's put first term over here. This is term number 1. First term. Second term, term number 2. Now, T2 is T2 minus 1 times a half, which means T1 times a half. This is going to be 64 times half. What is half of 64? It's 32. Alright. What about the third term? T3 is T3 minus 1, which is T2, the previous term, times half. It is 32 by half. Half of 32 is what? 16. If you continue, you're going to see that the fourth term, term 4, will be 8. The fifth term, term number 5, will be 4. The sixth term will be half of 4, which is 2. The seventh term will be half of 2, which is 1. The eighth term will be half of 1, which is half. The ninth term will be half of a half, which is a quarter, and so on. Now, the terms, as you go on and down and down, it will approach 0. It will not really reach 0, but it will get closer and closer to it as you go on. Because you're going to get 1, 8, 1, 16, 1, 32, but no matter how many terms you try, they will get smaller and smaller and get closer and closer to 0, but will not actually reach 0. So you can say, sometimes in mathematics, they say it tends, the terms tend towards 0. Alright? So they tend to 0. So that's a convergent sequence. It converges. If you do physics and you talk about your converging lens, right? Or your convergent lens, the beams of light rays coming in parallel to each other. They go to a particular point, so they converge down to a particular point. So that's a converging lens. Converge means you cram down everything. Everything goes towards a point. Alright? Now, let's look at another convergent sequence. Suppose you have the term in a certain position is equal to, let's say, that position divided by that position plus 1. What would be the terms? Suppose you start with 1. Term 1 equal 1. Now, term 2 would be 1 over 1 plus 1, which is a half, alright? Term 3, the third term would be 1 over 1 plus 2, which is 1/3. Term 4 would be what? 1 over 1 plus what? Oh, yeah. Term, oh no, I'm mixing it up. Let's start again. Term 2 is term 2, not term 1. Term 2 would be 2 over 2 plus 1, right? Which would be 2/3. Because I said TP is P over P plus 1. Term 3 would be 3 over 3 plus 1, which is 3/4. Term 4 is 4 over 4 plus 1, which is 4/5, and so on. What would be term 50? It would be 50 over 50. Let me rewrite this 50 over 50 plus 1, which would be 50 over 51. What would be term 100? It would be 100 divided by 100 plus 1, which is 100 divided by 101, and so on. What do you think this will approach? Well, as we get closer, as we move further and further, you see the answer, right? Oh, term 1, my mistake. Let's correct this. Term 1 would be 1 over 1 plus 1, which is a half, right? So here, term 1 is 1 over 1 plus 1, which is a half. Term 2, 2 over 2 plus 1, which is 2/3. Term 3, 3/4. Term 4, 4/5, and so on. Term 100 is 100 over 101. Term 1000, which is 1000 over 1001. So what would this approach? Well, if you think about it, right? Let's say Tn, whatever that number is. The arrow sometimes used for tends to, right? It will approach 1. It will tend to 1. Because if you go term 1 million, it is 1 million over 1 million and 1. It's like 0.99999 something, right? As you go on and down, you get 0.999999 more nines. So it will approach 1. So it tends to 1. So that's a convergent sequence. All right. Now, let's look at another type of sequence that you call a divergent sequence. You might remember, if you did physics before, the diverging lens would take these rays coming in parallel to each other and they would diverge, right? So these are diverging lens. The one in the middle would not go up nor down, but others would diverge, so they spread out. To diverge means to spread out, open up, all right? So if we have a sequence, the Tn is equal to the previous term, Tn minus 1, say plus 1. The first term, let's say the first term is 1, right? The first term is 1. Second term is 1, the previous term 1, plus 1, which is 2. The third term would be the previous term 2 plus 1, which is 3. The fourth term is the previous term, which is 3 plus 1, which is 4, and so on. Now, it's getting bigger and bigger. The numbers are getting bigger and bigger, so it's divergent. If you should plot a graph terms 1, 2, 3, 4, 5. These are the terms, right? The numbers would be 1 to 1, then 2, second term, so 2, 3 to 3, and so on. So once it's spread out like this, it's divergent. By the way, the convergent sequence, the graph of it would go down towards a particular value, whether to 0, 1, or whatever it is. It would go down towards a value, but the divergent sequence will go up towards infinity. Alright? So that's a divergent sequence. Suppose you have times 2 times the previous term. So if you start with 1, the second term would be 2 by 1, which is 2. Third term would be 2 by 2, which is 4. Fourth term, which is third. The fourth term was so 4 by 2, which is 8. Next term, we did this before, but we want to see whether it's divergent or convergent. 8 times 2, which is 16. So if you should plot the graph, you would see it going up like this. So it's divergent. It's spreading out, right? And as you go on and on, the answers would get larger and larger. So in that case, it's divergent, getting bigger and bigger. So in this case, the divergent sequence does not approach one particular value, right? The numbers get bigger and bigger, larger and larger. So that's divergent sequence. So look at the sequence. That's the set. These line of numbers where one number is gotten from the previous number going through a certain formula. The convergent sequence, it tends towards one particular value. As you go on and on with the sequence, right, adding more and more terms, you will see that the answers you get are getting closer and closer to a particular value, whether it is 0 or 1 or some other number. The divergent sequence, it's spread out. The answers as you go along get larger and larger, go towards infinity. And by the way, another divergent sequence you might get is say negative 2 times the previous term times t to the n minus 1. If you have this and you start with 1, this next term would be, say, negative 2 times 1, negative 2. Negative 2 times negative 2 would be positive 4. Negative 2 times positive 4 would be negative 8. Negative 2 times negative 8 would be positive 16. So it keeps switching from negative to positive. So if you should plot that graph of it, you'd start at positive 1. Then you go down to negative 2. And you go up to positive 4. Right? So 1, it would have both positive and negative sides to it. So this is negative 2, and this is positive 4. Then it swings back down to negative 8. Negative 8 would be down here. So negative 2, positive 4, negative 8. Then it swings back up to positive 16, and so on. But whatever the case is, you see the answers are spreading out. They would spread from here. The answers would be spreading out, right? Still getting either increasingly positive or increasingly negative. But you can see it's divergent. Alright? Now, what is a series? Well, simple. It's just what happens when you add the sequence. Alright? So if you say 1 plus 2 plus 4 plus 8 plus 16. If you add the terms of the previous sequence we looked at, we get what you call a series. So the series, just add the terms. And what you get is a series. Alright, so that will be it for now. I will see you in the next video.